Hi, ladies and gentlemen, your daily dose of Dorfler here. I don't know if I said it in the last video or not. Anyway, today's video is just going to be rather brief. I just wanted to kind of go over a couple of examples from your homework to just kind of let yourself check to see if you are going about these, whatchamacallits, problems the correct way here, these redox problems. So I'm just going to do a couple here. Let's look at number 2 here, okay? It's already balanced for you. So 2Li plus S yields Li2S, okay? Well, I'm going to write that down on my little whiteboard here. All right. So going to the camera here. All right, so let's look at the reactants first. All right. This is lithium. This is sulfur. Okay, they are both in their elemental or natural state. So that means this has an oxidation number of 0. This has an oxidation number of 0. Okay. So then we can come over here. We can go about this a couple different ways. We could just, we could go by the rules and, talk about metals being typically their ionic charges. But we could also say, you know what, I don't know what lithium's going to be here. Okay. So I could set this up mathematically. It is equal to 0. Okay. I know lithium is what I'm searching for. So I give that an X. And I know that there are 2 of them. And I know that it's with sulfur. And it's typically a -2. So solving for X, okay, that'll be a +1. So that means that lithium will be a +1, and sulfur is going to be a -2. So, again, this is number 2 on your homework. So that means that lithium went from a 0 to a +1, became more positive, and sulfur went from a 0 to a -2, meaning it became more negative. So in order for lithium to become more positive, it has to lose electrons. And using our old saying, oil rig, oxidation is loss of electrons, reduction is gain of electrons. That means lithium is oxidized. And sulfur is reduced. Let's do another example here. Let's go to number 4. Okay, so we see here with number 4, 3Mg plus N2 yields Mg3N2. Okay, so we have 3Mg plus N2 yields, excuse me, Mg3N2. So again, you can kind of pick your way you want to go. You can even, in this instance, this is an ionic substance, so you could go and say, kind of go reverse whooping, and you could say that, put this back up here, put that back up there, and you'll have Mg2 plus and, excuse me, an N3 minus. You can check that by doing what we've done previously up here and solve it mathematically. Again, it is a neutral compound, set it equal to 0. Okay, let's say we want to solve for, hey, let's try different. We want to solve for N. Okay, so according to this, our formula here, there are 2 nitrogens, so 2X, okay, and there are 3 magnesiums, and magnesium is typically a 2 plus, okay, so we get 6 plus 2X yields 0. Solve for X, we would get -3. So it all works out the same. So we have to figure out who is oxidized, who is reduced. Magnesium, elemental form, so 0. Nitrogen, elemental form, so 0. So Mg went from a 0 to a 2 plus, meaning it became more positive, so it lost electrons. So magnesium was oxidized. Nitrogen went from 0 to -3, therefore it was reduced. It gained electrons. So let's do one more. sample. Okay. Let's look at number 9. Okay. Excuse me. Number 9, we've got Mg plus 2HCl yields MgCl2. Again, they just do-si-doed plus H2. Okay. So, since this one's a little more involved, I'm going to go ahead and do, it's a balanced molecular equation here. Okay. So I'm going to go do the ionic. It's going to simplify my life a little bit. So Mg plus, okay, hydrochloric acid is a strong electrolyte. So we have 2H plus 2Cl minus. Again, that coefficient of 2 has to go into everything. Yields, Mg2 plus. Again, magnesium chloride is a strong electrolyte because it's an ionic substance. Plus 2Cl minus plus, 2H. Okay? So now we have to identify who the spectator ions are. Magnesium goes from a 0 to a 2 plus, so it changed. Hydrogen goes from a plus to a 0 because it's H2 is its natural state. Chloride ions, 2Cl minus, is the same on both the left and right. So that's our spectator ion. So our net ionic is going to be Mg plus 2H plus yields Mg2 plus 2H. And so we have magnesium and hydrogen. Okay, magnesium went from 0 because it's elemental to 2 plus. Hydrogen went from plus to 0 because it's elemental over here. So going from 0 to 2 plus, magnesium was oxidized. It lost electrons. Hydrogen went from plus 1 to 0. So that means it gained electrons, so it was reduced. So there's a few examples from your homework to kind of give you an insight into how you go about this. Also, for you to see if you are on the right path when solving these problems, okay? So again, short video. You have the other 7 or so questions, I believe, for you to answer. I'm going to end this video just so I could touch base with you. I may or may not be on Google Classroom. I'll try to remember to be on Google Classroom in today's whatever, but just check if you have any questions. Otherwise, you can send me an email. Have a good day, everybody. We'll see you later. Bye-bye.